Welcome to Math Technique and Math Huhusay na learners. Ma'am Annalyn here, and today we are going to tackle the learning competencies covered in your learning activity sheet, Quarter 1, Week 5 and 6. So, what are you waiting for? Grab your pen and notebook and of course your copy of your learning activity sheet, Quarter 1, Week 5, and let's get started. At the end of the lesson, you are expected to 1. Illustrate the rectangular coordinate system and its uses. 2. Illustrate and find the slope of a line given 2 points, equation and graph. 3. Illustrate linear equation in 2 variables. And 4. Write the linear equation ax plus by equals c in the form y equals mx plus b and vice versa. To begin, let us explore the parts and uses of the rectangular coordinate system, or also known as the Cartesian plane. Did you know why it was called the Cartesian plane? René Descartes invented the coordinate plane, which is why it can also be called the Cartesian plane. There is a legend that René, sick in bed as a child, came up with the coordinate plane when he tried to describe the location of a fly on the ceiling. The rectangular coordinate system is composed of 2 axes, the horizontal or x-axis and the vertical or y-axis. The coordinates of the x-axis are called abscissa, while the coordinates of the y-axis are called ordinate. Every point on the plane is named using the ordered pair xy. The 2 axes intersect at a point called origin, whose coordinates are 0, 0. The plane is divided into 4 regions called quadrants, counting counterclockwise. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Looking at the plane, you see that the coordinates on quadrant 1 are both positive. On quadrant 2, the coordinates are negative, positive. On quadrant 3, both are negative. And on quadrant 4, the coordinates are positive, negative. Take a look at how the rectangular coordinate system is used in locating position. Say the boy is at the origin. This is his reference point. How does the boy get to his house? Yes, the boy will take 5 steps horizontally. And then, he will take another 5 steps upward. So the point where the house is located has the coordinates 5, 5, where the first 5 is the x coordinate and the second 5 is the y coordinate. I bet you can give me the coordinates of the point where the school is. Yes, the coordinates of the point where the school is located are -4, 5. Can you now give the coordinates of the point where the market is? Yes, you are right. You go 3 steps horizontally and then go down 5 steps. So the coordinates are 3, -5. Finally, can you give me the coordinates of the point where the park is? Perfect! It's -2, -1. For this one, I want you to give the coordinates of the points where the book, the pencil, and the eraser are. I'm giving you 15 seconds to do that. Time starts now. Alright, time is up. Let's see. What are the coordinates of the point where the book is? Did you write 2, 1? If you wrote 2, 1, then you are correct. What about the coordinates of the point where the pencil is? Is your answer -2, 4? Great! And last, what are the coordinates of the point where the eraser is? I bet you wrote -2, -3, and that is correct. Perfect! You are doing great! You are indeed matatalino learners. What if we connect point A to point B? What do you think is formed? Very good. We form a line, and every line has a slope. We use the following visual descriptions for slope: uphill, downhill, and horizontal. Each has a slope. What about vertical? What is its slope? That we will find out as we go on through our discussion. The slope represented by the small letter m tells us how steep a line is. It is solved using the formula change in y over change in x. In symbol, we have m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The slope may be associated with the path you take in every step of your life. In life, one must have a target. One has to carefully plan his track to get to his destination and succeed. When we plan, we consider how steep the road or the path we will take. Of course, no one would ever take the steepest. To find the slope of a line, we name at least 2 points. The first point has the coordinate 0, 2, and the second point has the coordinates 3, 4. By using the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, we solve m equals 4 minus 2 over 3 minus 0, and so m equals 2/3. We can also use the concept rise over run. We rise first before we run. Going up, it's positive. Going down, it's negative. Going to the right is positive. Going to the left is negative. So from the first point 0, 2, we rise 2 steps. So rise equals 2. And then from that point, we go to the right 3 steps. So our run equals 3. And so slope equals 2/3. The line leans to the right, and the slope is greater than 0. It is positive. What if the line leans to the left? Again, we name 2 points on the line. The first point has the coordinates -2, 3. The second point has the coordinates 1, -1. By substituting the values in our formula, we have m equals 3 minus -1 over 2 minus 1. And so m equals 4 over -3. And so m in standard form is negative of 4 over 3. Using the rise over run, from the point whose coordinates are 1, -1, we rise 4 steps, and then we go to the left, we have -3. And so the slope is negative of 4/3. The line leans to the left, and so the slope is less than 0, and it is negative. Let us find the slope of a horizontal line. Naming 2 points on the line, the first point whose coordinates are -2, 5, and the second point has the coordinates 4, 5. Substitute these values in our formula. We have m equals 5 minus 5 all over 4 minus -2. And so m equals 0 over 6. And 0 divided by any number is always 0. Using the rise over run, of course we do not rise because it's just a horizontal line. So rise is 0. And then run, from the point whose coordinates are -2, 5, we run 6 steps, and so the slope is 0. The line is horizontal, the slope is 0. Finally, let us find the slope of a vertical line. Let's name 2 points on the line. The first point has the coordinates -4, -2, and the second point has the coordinates -4, 3. Substituting these values in our formula, we have m equals 3 minus -2 all over -4 minus -4, and so m equals 5 over 0. A number divided by 0 is meaningless, so m is undefined. Even if we use the concept rise over run, we rise 5 steps, but we do not run anywhere else horizontally, so run equals 0. And again, 5 divided by 0 is undefined. And so, if a line is vertical, the slope is undefined. I know you can do this very fast and easily. Identify the slope of each line as positive, negative, 0, or undefined. Let's have the first one. What is the slope? Very good, it's positive. Next. Great, it's 0. Next. Of course, it's undefined. And last, it's going to the left. The line goes down, and so it's negative. Let us do some solving. Find the slope of each line passing through these given points. Again, we will use the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 to find the slope of each line passing through these 2 points. For number 1, the first point has the coordinates 5, 2, and the second point has the coordinates 6, 1. For you to answer this very easily, label the coordinates as x sub 1, x sub 2, y sub 1, y sub 2. So for this one, let's say our x sub 1 is 5. So this must be our y sub 1. And then 6 is our x sub 2. So y is our y sub 2. So using the formula, we simply substitute the values. M equals our y sub 2 is 1. Our y sub 1 is 2. Our x sub 2 is 6 minus our x sub 1 is 5, and then performing the operation, 1 minus 2 is negative 1 and 6 minus 5 is 1. In standard form, it's negative 1. So our slope is negative 1, and the line is going downhill because the slope is negative. It's less than 0, so the line leans to the left. What about number 2? Again, negative 2 is our x sub 1, 1 is our y sub 1, 3 x sub 2, and 2 y sub 2. By substitution, m equals y sub 2, we have 2, minus y sub 1, which is 1, and then x sub 2 is 3 minus x sub 1 is negative 2. And so performing the operation, 2 minus 1 is 1. 3 minus negative 2, so this becomes positive 2. So 3 plus 2 is 5. So the slope is 1/5. It's positive. Therefore, the line leans to the right. The line is going uphill. So, for number 3, 4, and 5, I leave you these 3 items as your assignment. We are done with the slope of a line. What about writing the equation of a line? Let's start with defining a linear equation. A linear equation is an equation that is written for 2 different variables. The highest and the only degree of both the x and the y variable in the equation should be 1. Given these 2 points A and B, whose coordinates are 0, b, and xy respectively, we draw a line. How do we write the equation of this line? We will use the formula for slope. By substituting the values, we have m equals y minus b all over x minus 0. So, m equals y minus b all over x. By cross multiplication, we have m times x is mx equals y minus b. And this one can be written as mx plus b equals y by applying the addition property of equality. Y equals mx plus b is the same as mx plus b equals y, where m is the slope and b is the y-intercept. That is why it is called the slope-intercept form of a line. Let us apply what we have just discussed in finding the slope and the y-intercept of each line written in the slope-intercept form. To do this, always have your guide. Always write the slope-intercept form of a line. So we have for number 1, y equals 2x plus 5. So obviously, the value of m is actually the coefficient of x and b is the constant term, and so we write the slope is 2, it's positive, therefore the line leans to the right, and our y-intercept or b is 5. The y-intercept is the point on the graph that crosses the y-axis. Number 2, again, you use the slope-intercept form of a line, and then we plot y equals negative x plus 7. Your m is the coefficient of your x variable. What is the coefficient of x here? Very good, it's negative 1. When the coefficient is 1 or negative 1, you simply write the variable x with a sign, whether it's positive or negative 1. And then, we write m equals negative 1. What about our y-intercept? Very good. B equals 7. And finally, again, we write y equals mx plus b. For number 3, the given equation is y equals 1/3 of x minus 1. What is our slope? Very good, it's 1/3. What about the y-intercept? Perfect, it's negative 1. Let's go back to this previous illustration of a line and let us find out how we could write its equation in the slope-intercept form. Using the form y equals mx plus b, we first find the slope. Let's use the faster way, and it's the rise over run. So from point where the eraser is, the coordinates are negative 2, negative 3, we rise. How many steps? 4 steps. So it's positive 4. And then we run to the right. Again, we run 4 steps. So m is equal to 4 over 4, rise over run. And 4 over 4 equals 1. So that is our slope. The slope is 1. Next, we find the y-intercept. Remember, the y-intercept is the point where the graph crosses the y-axis. And in this case, our y-intercept is the point whose coordinates are 0, negative 1. And so, the value of b is negative 1. Substituting the values now to our y equals mx plus b, we have y equals m is 1, quantity x, plus b is negative 1. And so, we have y equals x minus 1. Let's practice. Write the equation of the line given its slope m and y-intercept b. For number 1, m is 3, b is negative 2. So again, we use the slope-intercept form of a line y equals mx plus b, and then simply substitute the value of m and the value of b. So in this case, we now have y equals m is 3, so we have 3x, and b is negative 2, and so this is the equation of the line whose slope is 3 and whose y-intercept is negative 2. What about number 2? I bet you can do it very fast. So we have y equals, what is our m? Our m is 1/2, so change it to 1/2, and then x. And then b is 3, it's positive, so we have plus 3. And so we already have the equation of the line. And number 3, again, y equals, our m is negative 1. So what did I tell you? If it is positive or negative 1, you do not write 1 anymore. Simply write negative x. And then our b is 4. Positive 4, and we're done writing the equation of the line given the slope and the y-intercept. The equation of a line can be transformed from the slope-intercept form to the standard form and vice versa. The equation y equals negative ax over b plus c over b, where negative a over b is the slope and c over b is the y-intercept. The standard form is ax plus by equals c. How did that happen? In the equation, the slope and the y-intercept are fractions. To remove the fraction, we multiply the whole equation by the common denominator b. b times y equals by. Negative ax over b times b is negative ax. C over b times b is c. Notice that in the standard form, both the variable x and the variable y are on the left side of the equation, while the constant term is on the right side of the equation. To have both by and negative ax on the left side of the equation, we apply the addition property of equality. We add the additive inverse of negative ax, and the additive inverse of negative ax is positive ax. Why do we add the additive inverse? So that we eliminate the variable x on the right side of the equation. And since this is an equation, whatever we added to the right side of the equation must also be added to the left side of the equation. And so we have ax plus by on the left side of the equation, while on the right side, since negative ax plus ax is 0, what remains on the right side is c. And there you have it. We now have the standard form of a linear equation. How about changing from the standard form to the slope-intercept form? How do we rewrite ax plus by equals c into the slope-intercept form y equals mx plus b? In this form, y is isolated on the left side of the equation and its coefficient is 1. To rewrite ax plus by equals c in this form, we apply the addition property of equality again. So we add the additive inverse of ax, and the additive inverse of ax is negative ax. So we have ax minus ax plus by on the left side. Again, this is an equation, therefore whatever we added to the left side of the equation must also be added to the right side of the equation. So we have negative ax plus c on the right side. Now, ax minus ax is 0. So what we have here on the left side is by equals negative ax plus c. Still, the coefficient of y is not yet 1. So to make the coefficient of y 1, we divide the whole equation by b. And so we have by divided by b equals y equals negative ax over b is, of course, negative ax over b plus c over b. And there you have it. The slope-intercept form of ax plus by equals c is y equals negative ax over b plus c. Let us write y equals negative 3x plus 2 in standard form. Remember, in the standard form, the variable x and the variable y are both on the left side, but the constant term is on the right side. So to write y equals negative 3x plus 2 in standard form, we add the additive inverse of negative 3x to both sides of the equation. So on the left side, we have 3x plus y. And on the right side, we have 3x minus 3x plus 2. Then we have 3x plus y on the left, but 3x minus 3x is 0, so we only have 2 on the right. So there you have it. We already wrote y equals negative 3x plus 2 in standard form. What about changing 4x plus 2y equals 2 into slope-intercept form? Remember, in the slope-intercept form, y is isolated on the left side of the equation. So to write 4x plus 2y equals 2 in the slope-intercept form, we add the additive inverse of 4x to both sides of the equation. So we have 4x plus its additive inverse negative 4x plus 2y equals negative 4x plus 2. Negative 4x minus 4x is 0, so what's left on the left is 2y equals negative 4x plus 2. So that the coefficient of y becomes 1, we divide both sides of the equation by 2. We divide both sides of the equation by 2 because this is equality. Whatever is done to the left side must also be done to the right side. And so 2y divided by 2 is y equals negative 4x divided by 2 is negative 2x. And finally, 2 divided by 2 is 1. So there you have it. The slope-intercept form of 4x plus 2y equals 2 is y equals negative 2x plus 1. And that's it. We are done with a very broad topic covered in our last Q1 week 5. Hope you learned a lot today. Let me just leave you these questions to process and just give me your reason. Write your answers in your journal. For sure you know this very well. Number 1. What do you think will be the graph of y equals 2x minus 1? Why? What do you think will be the graph of y equals negative 3 halves of x plus 5 halves? Why? What do you think will be the graph of y equals negative 3? Why? Why is the slope of a vertical line undefined? And lastly, which is steeper? A line whose slope is 1/2 or a line whose slope is negative 1/2? Why? The rectangular coordinate system is not only useful in locating objects and finding the slope of a line, it is also used by artists in sketching. The grids are used to sketch objects like this. I bet you have that talent in sketching. Why don't you make your own sketches using the Cartesian plane? Come on, I know you can make one. Thank you for watching this instructional video, my dear math wizards. I am Ma'am Annalyn, your math Tiyagang virtual mentor. See you again in our next virtual instruction. Bye!